So before starting the tutorial, I would like you to name some basic electronic components. So at this time, many may be coming to your mind, and you may be coming out with many components like resistors. So here we are going to start with the basic concepts. That is, the circuit components are basically passive and active. In passive, it comes resistors, capacitors, and inductors. In active components, it comes diodes and transistors. Now we have definitions for the passive elements. It cannot generate energy by its own. They cannot process or amplify electrical signals by its own. They need external power for its operation. Dissipating and non-dissipating types are available here. In case of active elements, it can generate energy by its own. They can process or amplify electric signals by its own. They do not need external power for its operation. Now in this tutorial, we are mainly covering resistors. So resistors are passive components. Process of opposing electric current is called resistance and is measured in ohms. The device or component to offer resistance is called resistor. The two main functions are controlling the flow of electric current and providing desired amount of voltage in electric or electronic circuits. Each resistor is manufactured with a specified amount of resistance. It is a two-terminal device. They conduct in both directions, so lead polarities does not matter here. And this is an exact pictorial representation showing the use of the resistor. First one, electric flow and water flow without resistance is shown, whereby in the second figure it shows what happens when resistance is added in between. That is, there is less water flow, as in the similar circuit diagram there is low light glowing out when we inserted a resistance. Now we are coming on to specifications. See, broadly we will be covering types, specifications, standard values, marking, and color coding. Specifications. The resistor value. First one is the resistor value. The amount of opposition to the flow of current is what gives the resistance value. 0.1 ohm to many mega ohms are available here. Now the second one is a tolerance. The allowed variation permitted in the normal or the marked value of the resistor is what is tolerance. That is, actual value of resistor may be either greater or smaller than that of the indicated value by a factor given by the specified tolerance. Acceptable tolerance ranges from plus or minus 20% to plus or minus 0.001%. Now the third one is a power rating. It is a maximum wattage the resistor can dissipate without excessive heating. It is denoted in watts. It may be as low as 1/10th watt and as high as 100 watts. Now the fourth one comes thermal stability. This is indicated by the temperature coefficient specification, which is expressed in parts per million per degree centigrade. And smaller value of temperature coefficient means less variation of resistance value and higher thermal stability for the resistor. Now we come to the types of resistors. So generally the resistors are classified as linear resistor and non-linear resistors. Now again, the linear resistors is classified into fixed resistor and variable resistor. Now the variable resistor, it can be a potentiometer, rheostat, or a trimmer. Now again we come to the fixed resistor. We have the carbon composition resistor, wire wound resistor, thick film resistor, and the thin film resistor. Now again it is classified, that is, thick film resistors again classified as fusible resistor, cement film resistor, and metal oxide resistor. And the thin film resistor, it's divided into carbon film resistor and metal film resistor. Now the second classification, that is the non-linear resistor, can be a thermistor, a photoresistor, that is LDR, or a varistor resistor. Now we are coming to the first one, that is the linear resistors. The linear resistors, the resistors through which the current is directly or linearly proportional to the applied voltage. Now it is of two types, fixed and variable adjustable resistors. This shows the representation. Now comes to the fixed resistors. Fixed resistors, the values are fixed. It will not vary with applied voltage, temperature, and light intensity generally. Now it has four types, as we just discussed: carbon composition, wire wound, thick film, and thin film resistors. Now this shows you a picture of the carbon composition resistor where it's having color bands, plastic case and carbon composition clay which is inside that, and a lead. Carbon clay composition for resistive material, normally graphite. Tint copper leads are there, enclosed in plastic case to prevent entry of moisture and other harmful elements. The resistance decreases with increased amount of graphite filled in it, and cylindrical shape and normally brown in color with colored bands to indicate resistance value. The properties of the carbon composition resistors are low water resistors, are cheap, reliable, highly sensitive to temperature variation. Size of resistors are increased at higher power ratings. The characteristics, the available range is 1 ohm to 22 mega ohm, tolerance is 5 to 20%, temperature coefficient is 0.001 per degree Celsius, maximum power is 2 watt and the power range is 0.1 to 2 watt. In the case of wire bound resistor, length of wire wound around on an insulating cylindrical core. Wires of constantan and mag-running, high resistivity, low temperature coefficients are used. Entire structure is coated with an insulating material, baked enamel. The picture is shown here. It is less sensitive to temperature variations, while length, resistivity and size can be easily controlled to achieve resistor parameters accurately. The drawbacks is inductance formed due to the wire wound structure and makes resistor unstable. To avoid this, dual thread resistors is used. Now the applications that we see as DC and audio frequency applications, the use of heat sink. The characteristics, available range, tolerance, temperature coefficient, maximum power and the power range is given here. Now come to a thick film resistor. It is made by depositing a very thick layer of conducting material on insulating rod, tube or plate made of ceramic or glass. Fusible resistor, bulk property film resistor, made of thick film metal film photo etched on insulator. Tolerance is given, low noise, non-inductive, low temperature coefficient, and it works on high frequency. Ceramic film resistor is formed by placing a metal alloy coating along with insulating materials on ceramic substrate. This combination is then fired into a ceramic metal called cermet, available as axial lead and resistor networks. Now the third is metal oxide film resistor, manufactured by oxidizing tin chloride on a heated glass substrate. Now low noise, good temperature stability, and available with high voltage ratings. It's available at very high resistor values up to 10 power 6 mega ohm. Now the characteristics are given here regarding that. The thin film, coming to a thin film resistor made by depositing a very thin layer of conducting material on an insulating rod, tube or plate made of ceramic or glass. The carbon in that comes a carbon film resistor constructed by using film deposition techniques. In depositing a film of resistive material, may be carbon or some material onto an insulating substrate. The desired values of resistors obtained by either trimming the layer thickness or by cutting helical grooves of suitable pitch along its length. Contact caps are fitted on both ends and lead wires made of tint copper are welded to these. Cheap, low noise, good stability, wide operating frequency range are some of the characteristics. This is a representation and some of the characteristics are given here. Now the metal film resistor, made by depositing a very thin layer of metal on a ceramic or glass rod. Metal film is spiral cut to the desired resistance. The smaller than wire wound resistors, high accuracy, low temperature coefficient, low noise, excellent tolerance, reliability is available. Now it's costly. It's also known as precision type resistor because they have plus or minus 1% accuracy. Now the characteristics are listed here. Now we are moving on to the standard values in the next video.